Hello everyone, this side Manisha Mishra, Assistant Professor in Mathematics, Applied Science Department at Central India's Institute of Technology and Management, Gurgaon. And this college is affiliated to Maharshi Dhanand University, Rohtak. Right, so today I will discuss the topic of exact differential equation. So in previous session I told you exact differential equation and condition of exactness. So today I will tell you about if equation is not exact, right? Then what we will do, right? So there are 3 to 4 rules, and we will find an integrating factor. Then by the integrating factor, we will change our differential equation into an exact differential equation. After that, we will apply the solution as previous to not exact differential equation, right? So before starting the exact differential equation, I just want to share 2 or 3 exercises related to Bernoulli equations and exact differential equation. So right, this is your 3.6 exercise, and this exercise is related to Bernoulli differential equation, right? So guys, solve this exercise, and if you have any doubt in this exercise, if any doubt in any questions, then you can ask me, right? And there is another one exercise, and this exercise page number is 157, sorry. So this exercise is related to exact differential equation topic. So 3.6 is related to Bernoulli differential equation, and page number 157 is related to exact differential equation. So guys, solve these exercise, and have any doubt, then you can ask me, right? Now I'm going to start equation, the topic equation reducible to the exact equation. That means our equation is not an exact, and we will reduce that equation into an exact differential equation, right? Sorry. So if differential equation is not exact, then we have our first rule, right? So our first rule is, if del m upon del y minus del n upon del x whole upon n is a function of x alone, right? This function is this is a function of x, and we will calculate this value, and that value will is your fx. Then our integrating factor will be e to the power fx dx, e to the power integration fx dx. So that is your integrating factor. Now there is an example, then we will better understand by the example. So question is, solve 2x log x minus xy dy plus 2y dx. So first we need to check that this equation is exact or not. So compare this equation with m dx plus n dy is equal to 0. So as we do in our all questions. So your m dx, m means 2y is here. So m is equal to 2x. And dy, so your n is equal to 2x log x minus xy, right? Now we need to calculate del m upon del y minus del n upon del x. So just differentiate m with respect to y. So del m upon del y is equal to 2. Del n upon del x is equal to differentiate and partially with respect to x. So u into v will be applicable. So u as it is, that means x as it is, log x differentiation is 1 by x, plus x differentiation is 1 and log x, minus xy differentiation. So x differentiation is 1, so y will be remaining. Now we have our del n upon del x. So we need to calculate del m upon del y minus del n upon del x a whole upon n. So just calculate this value, then you can see that bracket minus 2 log x plus y upon x, 2 log x minus y. So that value will be cancelled out if we taking minus 1 is out, minus sign is outside. So 2 log x minus y upon 2 log x minus y, that will be cancelled out, and minus 1 upon x will be remaining. Now this is your fx. There is a value, and that value is in only in x form. That means this is your fx. So fx is equal to minus 1 upon x. Now integrating factor is e to the power fx dx. So e to the power integration minus 1 by x dx. So e to the power minus 1 by x dx, 1 by x integration is log x. So e to the power minus log x, e to the power log x minus 1, we apply the rule log m to the power n is equal to n log m. So x e to the power log, I told you that value will be 1. So x to the power minus 1, that means 1 by x is your integrating factor. Right, we can see that our function is in the form of x, integrating factor we are getting 1 by x. Now the what is the work of integrating factor? The multiplying by integrating factor in our equation, then our equation will be an exact differential equation. So on multiplying the given differential equation in equation 1, that means our given equation by 1 upon x, then we get our differential equation is, you can see, I just saw you, just see your question, 2x log x minus xy dy plus 2y dx is equal to 0. So this equation will be multiplied by 1 by x. So 2y dx plus 2 log x minus y dy whole upon x is equal to 0. Right, now 2y dx upon x plus 2 log x minus y dy upon y. So there is a 1 by x is missing here, so guys, sorry for this. You can write in your notes 1 minus y upon x, 2 log x upon x minus y upon x dy is equal to c. So that equation will be our exact differential equation. If you want to check, then you can also check that equation, right? No, just 1 minute. Okay, 2x log x minus xy. So you can, guys, taking x common outside, then that value will be cancelled out. Okay, right. 2x log x minus xy upon x, that means x you can taken in common outside in numerator and denominator, so both will be cancelled out. So you will get this line, right? So 2y dx upon dx, so on integrating both sides, so in dy terms we I told you that the solution of the n dy, that means not containing x. So this term is containing x, so that will be deleted and minus dy will be remaining. So on integrating both sides, then you will get 2y, 1 by x integration is log x minus y square upon 2 is equal to c. So our solution will be applicable same as it is in the exact differential equation, m dx plus n dy, and in n not containing the terms x. So this term is containing x, so that will be deleted in the integrating. And when we will apply integration on both sides, then it will be deleted, right? So guys, this is an exercise related to this rule. First, this is a rule first exercise, and this question is your first question, and 3, 4, 5 are here, so you can solve this question, right? Sorry, 1 is here, 2 is here, 3.8. So 1 2 1 2 and 3 4 5, right? So just solve these questions, and answer is also here, so you can tell your answer with these answers, right? If any problem in any questions, then you can ask me, right? Now, okay, we have our rule second here. So rule second is, if del n upon del x minus del m upon del y whole upon m is a function of y alone, then fy is equal to del n upon del x minus del m upon del y upon m. Then our integrating factor will be e to the power integration fy gy, right? So if this condition, this is our second rule, and this condition we will calculate your m and n, then partial derivative, then calculate fy. Then fy means your integrating factor will be e to the power integration fy gy, right? Now, here there is a example here. So solve y to the power 4 2y dx plus xy cube plus 2y to the power 4 minus 4x dy is equal to 0. So first line is our compare the given equation with m dx plus n dy is equal to 0. So m will be y to the power 4 plus 2y, n will be xy cube plus 2y 4 minus 4x, right? Now calculate del m upon del y, del n upon del x. So del n upon del x minus del m upon del y whole upon m is equal to y cube will, when you put all these value here, then you will get minus 3y cube minus 6 upon y cube plus 2. Then minus 3 is common outside, y cube plus 2 upon y cube plus 2. So that will be cancelled out. Minus 3 upon y will be remaining. So your fy is minus 3 upon y. Now you can calculate your integrating factor. So your integrating factor will be e to the power log y to the power minus 3. That means that value will be 1. So you will get integrating factor as 1 upon y cube, right? Now, on multiplying the given equation by 1 upon y cube, we get the exact differential equation. So when you will multiply that by 1 upon y cube into the equation, given differential equation, then that equation, this equation is your exact differential equation. Now for the solution, so we will, what we will do, we will do integrating on both sides. So taking integration on both sides, so y to the power 4 upon y cube. So that equation y to the power 4 upon y cube plus 2y upon y cube. So 1y cancelled, 3y cancelled out, only 1 will be here. So y dx plus 2 upon y square dx. And this equation, this term is containing x, this term is also containing x, so though both will be deleted, only 2y dy will be remaining. You can see, so now integrating on both sides, so that is your final answer. So rule 1 and rule 2 are related to each other, but there is no notation that rule 1 is applicable or rule 2 is applicable. You have to check your own self that which rule is applicable, right? You can apply first rule in the second equation, then you can see that no, we are not getting fx function, fy function, right? That means fx means function of x alone, fy means function of y alone. So you will not get the function of x alone. You will you can get y also there. So you have to check your own self that which one applicable, right? There is rule third. So rule second related exercise is 3.9. So 3.9 exercise is related to rule second, right? So solve this exercise. Now rule third is, if m is of the function is m is of the form of m is equal to y into f1 xy. So there is a, in rule third, there is a formation of a differential equation. If your differential equation is of the form of this one, then you can apply rule third. So if m is of the form of m is equal to y into f1 xy, and n is of the form of n is equal to x into f2 xy, then your integrating factor will be 1 upon mx minus ny, right? So there is an example. So solve y into xy plus 2x square y square dx plus x xy minus x square y square dy is equal to 0, right? So first our target is to compare the given equation with your m dx plus n dy is equal to 0. So you can see here xy. So you can delete xy from the whole equation. So dividing by xy, so you will get this equation. This is the equation 1. Now comparing with m dx plus n dy is equal to 0. So m, you can see here, m is equal to y into function of xy, n is equal to x into function of xy. That means our equation is in the form of this one. So our integrating factor will be 1 upon mx minus ny, right? Now m is equal to n is equal to, so calculate integrating factor 1 upon mx minus ny. So one of integrating factor is your 1 upon 3x square y square. On multiplying 1, that means this equation by 1 upon 3x square y square. So just multiply this equation by your integrating factor. So that equation is your exact differential equation. You can see this equation is your exact differential equation, right? Now you are getting 1 upon 3x square y plus 2 upon 3x dx plus this is equal to 0. So next step is on integrating both sides. So you can see here there is an x term, so that will be deleted, and only the 3 terms are remaining. So integrating with respect to x here, with respect to y here. So you will get 1 by x square integration is x to the power minus 2 plus 1 upon minus 2 plus 1. 1 by x integration is log x, and 1 upon y integration log y. So this is your final answer. So rule third related exercise is your 3.10, and this is here, I think in the last page. So don't worry about it, I will share. I've already added a page of rule third exercise. Now next, our rule is our 4. So rule 4 is, if the given equation m dx plus n dy is equal to 0, right, is homogeneous equation. Here, what is the meaning of homogeneous term? That means the power will be same. If you are getting same power, that then you can say that equation will be your homogeneous. So m dx plus n dy is equal to 0 is a homogeneous equation. And another one condition is mx plus ny does not equal to 0, then 1 upon mx plus ny is an integrating factor. If your equation is homogeneous and your mx plus ny does not equal to 0, then you can say that your equation is an 1 upon mx plus ny is your integrating factor, right? Now there is an example here, right? So we will better understand by the example. Dy upon dx is equal to x cube plus y cube upon xy square. So just cross multiply, because we need m dx plus n dy. So just after cross multiplication, you will get xy square dy is equal to x cube plus y cube dx. So x cube plus y cube dx minus xy square dy is equal to 0, right? Now compare with m dx plus n dy. So you can see that m is equal to x cube plus y cube, n is equal to minus xy square. So your integrating factor. Now what is homogeneous condition? Here power is 3, here power is 3, right? Total power is 3. So our degree is 3, right? Now xy square total power is also 1 plus 2, 3. That means this is our homogeneous equation in m and n, right? Now you can check here also, 3 power, 3 power, and also in denominator 3 power. That means this is a homogeneous equation, right? Now integrating factor will be 1 upon mx plus ny. So after solving this term, you will get 1 upon x to the power 4 as integrating factor. Now next step is multiplying the given differential equation by 1 upon x to the power 4. So given differential equation is your x cube y cube dx plus minus xy square dy is equal to 0. So the 1 by xy, 1 upon x to the power 4, multiply on multiplication both sides. So 1 upon x, after solving this equation, you will get 1 by x plus y cube upon x to the power 4 dx minus xy square upon x to the power 4 dy. So after solving this, you will get finally this line is your final line. Now on integrating both sides, so you can see that this term is containing x, so that will be 0, and 1 by x integration is log x, and 1 upon x to the power 4 integration is x to the power minus 4 plus 1 upon minus 4 plus 1, right? So this is your final answer. So guys, if your equation is homogeneous, and for the homogeneous condition, you can check that your power, your degree will be same in numerator, denominator, whatever is given. So right, check, you can check here the 3 3 3, so all are same power. That means our equation is homogeneous, right? Now there is a rule 5 here, and for of this type of differential equation, this is a typical rule. So guys, we understand carefully, because there are 3 to 4 2 or 3 terms here, so you have to calculate, right? So x to the power m, y to the power n, ay dx plus bx dy plus x to the power m dash y to the power n dash a dash y dx plus b dash xy dy is equal to 0. If your equation is in the form of this one, then our integrating factor will be x to the power h, y to the power k. So first you have to calculate your m and a, b, m dash, n dash, a dash, b dash. Then you will calculate your h and k. Then after that you will write the value of h and k. That value will be your integrating factor, right? So for the solution of m, n, a, b, m dash, n dash, a dash, b dash, you have two equations. m plus h plus 1 upon a is equal to n plus k plus 1 upon b, and m dash plus h plus 1 upon a dash is equal to n dash plus k plus 1 upon b dash. So these are the two equations. So you will put all these value here, except h and k, then you will get two equation in h and k. Then solve that equation, solve these equation, then you will get the value of h and k. After that you will put here, right? So there is an example. So first one, solve this equation. So we need to convert, you can see here m dx plus n dy, right? But our equation here, this equation is in the form of ay dx plus bx dy. That means dx dy are combining with each other. So you have to convert this equation into this form, right? So convert this equation in this form, you have to multiplication all these value and have to arrange also. So y cube dx minus 2x is, square y dx plus 2xy square dy minus x cube dy, right? You can see here. Now ay dx, so y dx, that means here x to the power m, y to the power n. So y square is common here. Here you can see that y cube dx plus 2xy square dy, this value, right? So you can combine both these, and remaining two will be here. Now y square is common here, so you can take y square outside. So y dx plus 2x dy plus x square is common here, minus 2y dx minus x dy is equal to 0. So now our equation, this one and both above one, both are same. So compare with this equation with this one. So now you will get here m is equal to 0, so m 0, n is equal to 2, you can see that n is equal to 2, y dx, so a is y coefficient a is 1 here, bx dy, b means 2 here, and x square, that means m dash is 2 here, n dash is 0 because no y term is here, a dash minus 2, b dash minus 1, right? You have your all values. Now next step is put all these value here, right? So you will get m plus h plus 1 upon a is equal to n plus k plus 1 upon b, and m dash plus h plus 1 upon a dash is equal to this one. So write these value here. So you will get after cross multiplication, you have an equation 2h minus k is equal to 1, and h minus 2k is equal to minus 1, right? Now solve these two equations. So 2h minus k is equal to 1, h minus 2k is equal to minus 1. So you can multiply by 2 in the second equation. So h will be cancelled out. 3k is equal to 3, so k is equal to 1, so h is equal to 1. Put the value of k in equation 1, then you will get h is equal to 1. Now we have our h and k value, that, and the next step is put the value of h and k in our integrating factor. So integrating factor is your x, y here, right? Now multiplying the given equation by x, y, then we get xy to the power 4 minus 2x cube y square dx, means we are multiplying xy in the given differential equation. Then after that you will get this equation. Now for the solution, integrating on both sides, you can see here both of these terms are containing x, so that will be deleted, only these two terms will be remaining. So integrating these terms and you will get your final answer here. So there are 5 rules here, and I have discussed all the 5 rules, and there are exercises also here. So you will solve all the questions related to these rules, and have any doubt, then you can ask me. I told you. So the 3.10 exercise is related to rule 3rd, and 3.12 exercise is related to rule 4, right? So you will solve all these exercises, right? And in our next session, I will share, I will discuss the topic equation reducible to p, equation solvable for x, equation solvable for y. So that topic will be our next topic, right? And this topic, these topics will be discussed in our next session. Okay, thank you.